Okay, students, we're going to do a quick overview of Unit 11 so you can have a chance of understanding this and getting it right on the DCAS coming up in a couple weeks. After the DCAS, we'll do this unit in more detail and spend some more time on it, but we're running out of time, so I want to expose you to everything. We got this unit to do and one other unit that we're going to each do in a day. So just pay attention. The square root stuff we've started with already and dealt with, but we're going to add on to it now. We've only simplified before. All right, so in 1 and 2, we are adding and subtracting radicals. Okay, when you add and subtract a radical, in order to add and subtract them, it's like if I had 2x plus 3x. The x part would be what's underneath the radical. It has to be the same number. Okay, and then what do I do with 2x plus 3x? All I do is add the coefficients and be 5x. So let's say what was underneath the radical is 2 root 2 plus 3 root 2. Well, then that would just become 5 root 2. Like I said, the root 2's would be like the x. They have to be the same thing. And just like if I had 2x plus 3y, can I add those together? No, because they're not like terms. So if I have 2 root 2 plus 3 root 3, I cannot add those together because that root 2 and that root 3 are not the same. Okay, it's no different than if it's 2x plus 3y. They are not like terms. Okay, so in order to be like terms, they must have the same number underneath the radical. Then all you do is add the coefficients. Okay, so that's for adding and subtracting. Okay, so we need to reduce the radical. Remember, that'd be root 4 times root 3, which then is 2 root 3. So if I'm going to be able to add that root 75 to this 2 root 3, there must be a root 3 in here. So that's a dead giveaway. Remember, I told you you can't add them unless they have a like term. So there must end up being a root 3. So I can say 3 times what is 75? And that's 25. Okay. So then that simplifies to 5 root 3. And I have my 2 root 3. Now I see I have the same radical, same number underneath the radical. So I just add the coefficients. And the answer is 7 root 3. Okay, that's it. Same rule applies for subtraction. So notice root 7 does not simplify, does it? There's no perfect square that goes into 7, so it's done. So that means that's 1 root 7. Don't forget there's a 1 out front. So that means that this must have a root 7 in it if I'm going to be able to add them. And 7 times what is 28? 4. So I have 1 root 7 minus 2 root 7. Now notice I have the same square root, same number underneath the square root. So now I can add the coefficients, or in this case, subtract the coefficients. So 1 minus 2 is negative 1 root 7. And on a test, it would look like this. On a DCAS, just be negative root 7. They don't write the 1 down there. Okay? So that's adding, subtracting radicals. Now multiplying. As I showed you before, when we multiply, we want to, if we can't, I mean, you can simplify each one individually and then multiply them. That's one way of doing it. Another way is to find the GCF between the two. So I know 6 also goes into 24. How many times? 6 times 4 is 24. So these two multiply to that. Then I should remember from what we've done before, root 6 times root 6 is 6. It just takes off the radical. Remember that comes from root 36, and the square root of 36 is 6. So the short and simple way to remember is if I multiply two radicals together with the same number underneath it, all it does is take off the radical. And then, of course, root 4 is 2. So 6 times 2 is 12. Okay? Much simpler. Then you could have gone ahead and multiplied the 6 times 24, but this would be like without a calculator probably on the DCAS. So if you could multiply that, that's root 144, which then is 12. And so you get the same answer. But it's easier to deal with these smaller numbers. I could have also, the third way would be to reduce that. I have that root 6 that doesn't simplify, but root 24 simplifies down to 2 root 6. And then I see my root 6, and root 6 there is 6 times the 2 also is 12. Okay, so there's 3 different ways of getting that 12. I suggest you look for GCFs, as I did right here, this first method. Okay. Now, that's for multiplication. Division, what you need to know about division with radicals is you cannot have a radical in the denominator. So right now we have a radical in the denominator. Remember, a radical is called an irrational number. Okay. So what we have to do is called rationalize the denominator. That's the concept of what it's called, rationalize. What we're doing, we're changing an irrational number. Remember, I just told you root 3. Any square root that's not a perfect square is an irrational number. So I have to change that irrational number into a rational number. And how you do that is multiply it by that same radical. Okay? Or if that radical is simplified first, you could simplify it first and then multiply by what's underneath the radical. So root 3 times root 3 is 3. And root 10 times root 3 is root 30. And root 30 does not simplify. Okay, because we know root 3 doesn't simplify, root 10 doesn't simplify, and 3 and 10 does not have a GCF. So it'll be root 30 over 3 would be that answer. 3 is a rational number. Remember, anything you can write as a fraction, 3 I can write as 3 over 1. Anything you can write as a fraction or repeating decimal is a rational number. Okay. Now, on a side note, why am I stressing this rational number thing? Because on the DCAS, they could ask you, how do you get, if you have an irrational number, such as root 3, what do I have to multiply such irrational? What do I have to multiply it by to get a rational number? My answer would be another irrational number, such as root 3. Okay, and that gives me 3. Now it's a rational number. Okay, so that's why you have to know the difference between irrational and rational. Or it might say, what do you get when you multiply two irrational numbers together? Well, depending on the situation, if I have root 2 and root 6, okay, that just gives me 2 root 3. So that's still an irrational number. So it's not always just an irrational times an irrational. It needs to be the same irrational number. For example, that will take off. So if it asks you to explain how you know, you say, if I multiply an irrational number by itself, that is a rational number. So that's a side note. If they add about adding or subtracting irrational numbers, they remain irrational. Okay, if you add or subtract irrational numbers, unless they're the exact same number, such as root 3 minus root 3, right? That's then 0. Well, 0 is a rational number, but if they aren't, that's the only case it becomes rational. Otherwise, no matter what I add, if it doesn't come out to be 0, if I add or subtract rational numbers, they remain irrational. Okay, if I add or subtract rational numbers, they remain rational. Okay, so that's a problem that could be on the DCAS. So just know that. That's why I focus on that. All right, here we have simplifying. Up there we add, subtracted, and multiplied and divided. Now you also have a just simplified radical that we already have done before. So again, I'm looking for a perfect square that goes into it. Number start with half the number. Half of 8 is 4. That's a perfect square. And that gives me 2 root 2. Remember, since root 2 is not a perfect square, that is a irrational number. Okay. Square root of 225 is a perfect square. 15. 15 times 15 is 225. Okay. Let's say you didn't know that, and that was on a problem that was non-calculator. Well, if there's a multiple choice, you could take the answers and multiply them back out and see if it works. But you should know that any number that ends in 25, 25 has to go into it. Okay, and we know 25 is a perfect square. So how many 25s go into $2.25? Just think 225 is $2.25. We know there's 4 quarters in dollars, so 8 quarters in $2, and I'd have one more quarter, 9 quarters. Of course, root 25 is 5, root 9 is 3, and there you get 5 times 3 is 15. Okay, so even if you didn't know, even though I offered as extra credit, memorizing your squares, that's 225 is 15 squared, that would have been one of them. You can still break it down this way. Okay, all right, multiplication here. This is just distributive property. You've done it already with binomials. You know, now we're just dealing with radicals. It's the exact same way. Distribute. So I have root 18 times root 6. I'm just writing them out. I'm not multiplying them yet because I'm going to show you again like we did up top. Then I have root 18. It's a plus, so it's still plus root 18 times root 3. Then I have this minus root 2. Don't forget to have that negative sign with it. So minus root 2 times root 6. And then I have minus times a plus is also minus root 2 times root 3. Make sure you draw your arrows so you don't forget. Remember, when I have a binomial times a binomial, no matter what they are, I'm going to end up with 4 terms. There's my 1, 2, 3, and 4 terms. Remember, terms are separated by plus and minus signs. So there's 1 term right there. 1 term, 1 term, 1 term. 4 terms. Whenever you multiply binomial times binomial, you're going to get 4 terms. And then oftentimes you'll be able to combine some afterwards, okay, to go down from there. So how do we multiply the root 18 times root 6? Again, I look for the common GCF, root 6. Change 18 into root 6 times root 3, and then I have the root 6 right there. So that gives me 6 root 3, because I know root 6 times root 6 is 6. Can't simplify the root 3. Plus, I see 3 goes into both, so make that 3 times 6 for 18, and there's that root 3. Oops, let's move all this up. Right there, and I have root 3 times root 3 is 3, root 6. Okay. Then I have, that's small enough, you can multiply that together in your head, 12, and that simplifies down to 2 root 3. Or I could have left it as root 2 and then broken that down to 2 times 3. That gives me like 2 root 3 right there. And then lastly, that's just root 2 times root 3 is negative root 6. Okay. Remember, I now look to combine like terms. Where are my like terms here? A root 3 and a root 3. Got to have the same number in each radical. So 6 root 3 minus 2 root 3 is 4 root 3. Here's my other like terms, root 6 and root 6. Don't forget that's a 1 there. If you have to put a 1 so you don't forget it. 3 root 6 minus 1 root 6 is 2 root 6. So there's my answer right there. I can't combine those because those are not like terms. The root 3 is not root 6. It's like an x and a y, different terms. Okay. So that's the, that'll be lesson 11.1 right there doing that. Okay. Here's another one. Actually, this is also part of lesson 11.1 too. Solving equations using square roots. Oop, I forgot the letter U there. Square roots. Square, S-Q-U, forgot the U there. All right. So remember, these are all quadratics. If I look at them, they all are degree 2, so they're all quadratics. What does it mean to be a quadratic? It means there's 2 answers. I look at the exponent, the degree, the highest degree of any of the terms, tells me how many total answers are going to be. So I'm always coming up with 2 answers. Okay, remember we just did quadratics. We'd have 2 answers going through the x-axis if the parabola went through the x-axis. Okay, otherwise if it didn't go through the x-axis, you actually get 2 imaginary answers. We're in algebra 1, so we're not going to deal with imaginary answers. What imaginary answer is when you get it underneath a radical, if you get a negative number, like -4, that's an imaginary number. Okay, so if the parabola, going back to the quadratics, we have our xy, if the parabola opened up and it never crossed the x-axis, that would mean I'd have to use quadratic formula, which we're doing coming up here in this unit. I would get 2 imaginary numbers because they do not cross the real number line. Remember, this is the real number line. So if it doesn't cross it, they're imaginary. Okay, and that's considered imaginary when you deal with real and imaginary axes. Okay, but what happens in the quadratic formula, you get a negative underneath it. We'll see that coming up. Well, you're not going to see it because you're only dealing with algebra 1 and you're only coming up with positive answers. All right, so reverse PEMDAS. How do I solve all equations? Reverse PEMDAS. Now you're finally dealing with your exponents. We have all this time is staying down here at the algebra, the add and subtract level and the multiply and divide level. You have not gotten up to the exponent level yet. Now you finally are. Okay. So there is nothing to add or subtract across. There's nothing to multiply or divide across. I'm up to exponents now. I got to get rid of that 2, get down to a 1. The way you do that is you take the square root of both sides. Now, remember I told you there's 2 answers. So when you take the square root of both sides, you always have to put plus or minus over here. That's your 2 answers. So when I say square root, that means that radical right here, this is a 2. We don't ever write that. We expect you to know that. Just like when we say x right there, we expect you to know that's 1x. And we also expect you to know that's 1 for the exponent. Okay? Well, on a radical, when we write square root, square, I mean like squared, we expect you to know that's the 2 there for the squared, for square root. So it's never written. Okay? And then how you would simplify that, 2 divided by that radical 2 is 1. So it gets me down to x to the first, and then plus or minus, and what's the square root of 16? 4. So that means x equals plus or minus 4. There's my 2 answers. And I can check that. 4 squared is 16, and negative 4 times negative 4 is also positive 16. Okay, so remember, all these are quadratics. I mean, you're always going to have 2 answers. That means you're going to always have this plus or minus involved in all of your answers. Okay, so that was the simple one. We're working our way up. Okay, now notice I'd have a multiplying divide at this level right here to get rid of this 5 first. I don't deal with exponents until afterwards, so I divide by 5 on both sides. Now I'm down to x squared equals 4. Well, you should be able to do that in your head. What number squared it gives you 4, and that's plus and minus 2. Which of course I could show work like this, plus or minus. That gives me my plus or minus 2 right there. Okay, number 3. There's nothing to, this is parentheses way up here. So I'd still do with the exponent first at this level. So again, I take the square root of both sides, plus or minus. I'm just writing the plus or minus up there because I don't have any room to write in front of that equal sign. Okay, I'm trying to save space here. So again, that's that 2 divided by 2, so it gets down to x minus 1 equals plus or minus, and what's the square root of 1? 1. And now what's the last step? Add that 1 across. So now I have x equals 1. It's usually this 1 is added across and plus or minus 1. Well, that's 2 answers. I have to actually calculate. 1 plus 1 is 2, and 1 minus 1 is 0. That's not a point, 2, 0. That's 2 and 0. 2 different answers. Don't think that's a point. Okay, that's why you're not going to see me write parentheses around it. That would be a point. These are 2 answers. So that means if I plug 2 into there, 2 minus 1 is 1, squared is 1. Okay, I can always check. So even if you forget how to do this, you can take the answers. Oftentimes they're multiple choice in the DCAS and plug them back into the equation to see if it works. Plug in 0 in there. 0 minus 1 is negative 1. Negative 1 times negative 1 is also positive 1. So they work. You can check it every time whenever there's an equation. All right, number 4. 2 steps now. Okay, again, we're down at the bottom level. We need to add that 6 across. Okay, exponents are higher up. So now I have x minus 1 quantity squared equals 36. Now I'm up to the exponent level. So now I take the square root of both sides. And I can't forget that plus or minus. So I have x minus 1 equals plus or minus 6 because the square root of 36 is 6. Now I go ahead and add that 1 across. 1 plus or minus 6. What's 1 plus 6? 7. What's 1 minus 6? Negative 5. There's my 2 answers. That's not a point. Those are 2 separate answers. And you could check those by plugging them back in. Okay. Number 5. I just gave you more practice again, doing the same things again. So the worksheet you're going to get is going to be just like this, just different numbers. So you have this entire video to watch to review any of the steps. It's going to be the exact same steps as you have on yours, just with different numbers. Like I said, we're going through this quickly in order to make sure I can get everything exposed to you before the DCAS test. Okay. So again, square root, plus or minus, x equals plus or minus 6. Remember that degree tells me how many answers. You better have 2 answers. Here I have to divide division first before exponents. So I get x squared equals 9. Now I take the square root. m plus or minus. X equals plus or minus 3. Okay, here I'm right up to the square root right away. And nothing to add, subtract, or multiply or divide across. Square root both sides, plus or minus. So I have x minus 2. Remember that 2 divided by 2 cancels out to 1. Plus or minus 5. Add the 2 across. 2 plus or minus 5. 2 plus 5 is 7. 2 minus 5 is negative 3. So if you want to write them on 2 separate rows like that, you can. So you make sure that you don't write it as a point. Those are 2 different answers. And again, you could check it by plugging back in and it works. Okay, here 3. We need to go ahead, or number 8, we need to do add or subtract first. So we're going to add that 1 across. So I have x minus 5 quantity squared over 3 equals 4. 3 plus 1 is 4. Now I do the opposite of division, which is multiplication. Multiply by 3 on both sides. Cancel that out. Now I have x minus 5 quantity squared equals 12. Okay. Now I'm up to the radical level. This exponent rule, exponent level. So I have to, again, that tells me there's my 2 answers. Take the square root of both sides, plus or minus. Those 2 divided by 2 is 1, so I get x minus 5. And I have plus or minus. Now notice root 12 reduces, simplifies. That's 4 times 3, so that's 2 root 3. You should be able to do that in your head. Okay, you must simplify this. Okay, and what's my last step now? Add that 5 across. Opposite of minus is plus, so I have 2 plus or minus 2 root 3. And there's my 2 answers. There are my 2 answers. Okay, you might see it written like that, or they might have it written separately. 2 root 3, 2 plus 2 root 3, and 2 minus 2 root 3. Okay, not as a point, so they're not going to have parentheses around it. It's not a point. It's the 2 answers. Okay. All right. Next, complete the square. So that was 11-1, doing that right now. That right there. Now complete the square. And then we'll be doing quadratic formula. All right, complete the square. I spelled square right that time. Find C to make the expression a perfect square. That is going to factor into the same factor twice. Simple rule. First off, in the algebra 1 level, most of the time you're going to deal with only coefficients of 1. Remember, when it's not there, it means it's 1. Okay, I always get my quadratic term. Remember, that's my quadratic term because degree 2, that's my linear term, degree 1. And what I'm solving for is the constant term, C. Remember, that's A, B, and C in standard form. Remember, standard form, we just got done doing that all throughout the quadratic section right there. Standard form. If you write it in function notation, it'd be f of x. If it didn't have to be in function notation, it'd just be y equals. Remember, y and f of x are almost the same thing. All right, so how do you find this number? When the coefficient is 1, okay, it's always 1/2 of b squared. What's b? You got to remember that's the coefficient of the linear term. Remember, linear for 1, quadratic for 2. So b is right there. So what is half of b? Half of negative 20. Make sure you include the sign is negative 10. And then I square that. What's negative 10 times negative 10? 100. That's it. Okay, you're going to have a problem like that on a DCAS. It should be 3 points. If you remember this, it's 1/2 of b quantity squared. Make sure you put parentheses around it and square it. No different. So I give you 2 more practices with it. Okay, I'm just gonna write the half of b each time. You've got it right there. So half of b is plus 6, right? Half of 12 is 6. Squared is 36. Okay, that half of b again. There's my b. If you need to, circle it with the sign. Negative 8, half of b squared, 64. That's all you have to do to complete the square when the leading coefficient, remember that's called the leading coefficient, is 1. You should know that because you just got tests on the leading coefficient. That's simple. 1/2 of b squared is going to complete the square. So what does that really mean? That means this right here, x squared minus 20x plus 100 would factor into x minus 10 squared, which is then called That's why it's a square. It's complete the square. And what does that refer to? If I have a square, 4 90 degrees and 4 right angles, that means each side of the square in this case would be x minus 10. X minus 10. That's what it's really talking about if you were looking at a real world situation. Okay, and then so the area of that square would be x minus 10 times x minus 10, sides squared, right? Area equals sides squared. And so you get x minus 10 times x minus 10, which is right there. Okay, so that's what it means. Now you're not having to write that out. All you're doing is getting that 100. What makes your says find c, that constant term. This would factor into x plus 6 squared. Now, this is the reason. Now, you're going to need to know this for geometry. Like I said, we're going to practice more of that. You're going to actually complete 2 of them in one equation and come up with the equation of a circle. So you're going to prepare for geometry next year. You're going to do this in geometry next year, completing the square. Except for this has just got one of them. You're going to do it twice with the x coordinates and the y coordinates and come up with your center, x comma y, for a circle. We'll do that after the decals. All right. So that's what this be. The reason I have you write down that 1/2 b with that number in parentheses, because that's what's going to drop right into here. Okay, that's an easy way. You already know it's got to be x times x to give me my x squared, and the number here is always whatever 1/2 of b is. Okay, every single time. And so therefore this one would be x, drop it down in there, minus 8 quantity squared if they want it written out. If they were actually going to go beyond finding c. Okay, so there's that. So that was just finding c. Now we're going to solve the quadratic by completing the square. So now we're going to use that, what we did up top, those 3, to actually now solve. Okay. So in the solving, we get the quadratic term and the linear term on one side, move the constant term to the other side. So I'm going to have x squared minus 16x plus blank. And I want to hear you say plus blank. Equals, you're going to add that across. So that makes it 6. It better always be the opposite sign. The weaker Algebra 1 students end up doing the same sign and put -6 on the other side because they still haven't got it down that when you move a term across the equal sign, it's always the opposite sign. 6 plus blank. Because whatever I do, remember I got to find that c that we just did above. Whatever I do to one side, I must do to the other side. So I have plus blank and plus blank on both sides. We're finding that c. We already know how to do it. It's 1/2 of b squared. So half of b is -8. Squared is 64. So I added 64 on the left side, so I must add 64 on the right side, so I don't change the equation. And now I go ahead and factor that. Remember I told you, if you wrote that down, you already know what it is. X minus 8 squared equals 64 plus 6 is 70. Now I actually solve it. Remember we just did that in the last lesson. Okay, there's nothing to add, subtract, or cross because this is in parentheses. There's nothing to multiply or divide, so we're all the way up to the exponents. So we take the square root of both sides, and it's plus or minus. So I have x minus 8 equals plus or minus the square root of 70. Okay. Square root of 70 does not break down. Okay, that'd be 35 times 2. And 35 only breaks down to 5 and 7. So you have a 5, 7, and 2. None of those are perfect squares or simplify with perfect squares. So square root of 70 does not simplify. So the last step is to add that 8 across. So it becomes 8 plus or minus the square root of 70. If square root of 70 is simplified, I need to do that, but it does not. So there's my 2 answers. Remember, that's 2 answers. 8 plus square root of 70 and 8 minus square root of 70. Okay, so we're going to do that. It's those same steps again on number 5. So again, I move the constant across. I only have my quadratic term and my linear term on one side. The constant goes the other. Okay, so let's change the color here. Go to green. X squared minus 16x plus blank equals 10 plus blank. That's a plus sign. Remember, this is always half a b every time. Again, like I said, you got to memorize this for next year in geometry too. Write it down. What's half of b? -8. Squared is 64. So I must add 64 to the other side so I don't change the problem. Okay, that's going to simplify down to x minus 8 again. That's right there. Squared equals 74 this time. Again, 74 does not simplify either. That's 37 times 2. Both those are prime. So now I can go ahead and take the square root of both sides. I get x and equals plus, I'm just going to, since I'm running out of room, I'm going to do the 2 steps in one. I'm adding the 8 across also right now, so I get 8 plus or minus the square root of 74. Okay. So there's my 2 answers right there. Now, if they said round your answer to the nearest 10th or 100th, that would be a calculator problem then. And then I would type in 8 plus square root of 74 equal, enter. Get that decimal round to the nearest 10th or 100th. Then do 8 minus the square root of 74, enter, and round that to the nearest 100th. Okay, so these are exact answers. When you leave it in radical form like this, these are called exact answers. And then if they want a round answer nearest 10th or 100th, that's when you plug it in the calculator. Okay, so DCAS will have both. If they ask you to round it, then of course they have to, it has to be in the calculator portion. If they don't ask you to round it, it could be in the non-calculator portion. They want to see you do this right here. Okay, if you need to pause it because you haven't written all this down, go ahead and pause it. So I'm going to go ahead and erase all this so we have more room for number 6 now. Okay. All right. So notice in 4 and 5 and the ones above, they had a coefficient of 1. Notice this is a coefficient of 2, leading coefficient of 2. When I complete the square, I have to get it down to a 1. So since this is solving an equation, I can go ahead and divide each term by 2, okay, to get down to a 1. So now I have x squared minus 6x minus 1 equals 3. Am I going to leave it just like that to complete the square? No, you should be able to tell me right now what I have to move to the other side, because we've already done it twice now. I have to move the constant to the other side. The quadratic term and the linear term stay on one side, the constants to the other. So now I rewrite it, x squared minus 6x plus what? Blank equals, the 3 plus 1 is 4 plus blank. Okay, whatever I do to find that c on the left side, I'm going to add it to the right side. So remember, it's always 1/2 of b squared. So half of 6, negative 6, is negative 3. Squared is 9. So I must add 9 to the right side. So I did not change the problem. I'm running out of room, so I'm going to put it over here. So remember, that's going to factor into x minus 3, because there's my minus 3 if I've written it correctly with half of that b squared. That's what this whole thing factors into. Remember, x squared minus 6x plus 9 factors into x minus 3 squared. I'm just showing you the shortcut. If you put that minus 3 right there, that's what it's always going to be. But that's what you're really doing, is you're factoring x squared minus 6x plus 9. That's x minus 3 squared equals 13. 9 plus 4 is 13. Okay, again, there's nothing to add, subtract, multiply, or divide. We're all the way up to exponents. So I take the square root of both sides and plus or minus. So I have x minus 3 equals plus or minus the square root of 13. The square root of 13 does not break down at all. There's no perfect square that goes into it. So my last step is to add the 3 across. So I get x equals 3 plus or minus square root of 13. Notice you've never seen me write it as x equals plus or minus the square root of 13 plus 3, even though that's the same, okay, because this is a positive 3 right there. That's the positive 3 right there, so the signs are the same. It's never going to be written like this on the DCAS. They always put the one individual term and then they put the plus or minus in between. So get used to writing like that, even though those are the same answers. Okay, so that is another lesson in 11, is solve by completing the square. Complete the square, just get the c like we did up top, then also solve by completing the square. Remember, the coefficient needs to be a 1. So 4 and 5, they are already 1. I move the constants to the other side, completed the square. Number 6, the leading coefficient was a 2, so I had to divide every term by 2 to get down to that 1. I need it to be 1 right there. Then I go ahead and move the constant across, quadratic and linear term on the left side, put my plus blank and do half of b squared to fill in those blanks, and then go ahead and solve that quadratic. Okay, I'm going to erase this now. So if you haven't finished writing it down, go ahead and pause the video and write it down. All right, last section is called solve a quadratic by quadratic formula. Now, I pointed out last week when we're reviewing on the quadratics, remember, sometimes we could factor that quadratic and get the x-intercepts, okay, and go right through nice numbers like this. Let's say the parabola looked like this, okay? It went right nicely through two nice numbers on the, because we could factor it and get them on the x-axis. Well, you also had the point where you had to try to guess and just estimate or approximate where it went through between two integers. And I told you we're going to now, this unit, use the quadratic formula to find those exact answers. By the way, what we just did up here wasn't solving by completing the square. If I start with my function as this right here, when I solve those answers, those two answers were where that parabola crossed the x-axis. That's what it was. So that's one way of finding the exact answers if it didn't factor. You can solve it by completing the square. That's one way we just did it. Now we're going to do it by quadratic formula. So I've reminded you, here's standard form, ax squared plus bx plus c equals 0. Okay, get it set equal to 0. Standard form, remember standard form means highest degree down. Degree 2, degree 1, and then degree 0. It's x to the 0. Oh, that's what it means to put a polynomial in standard form, highest degree down. We've talked about this. I've also given you the quadratic formula right here. This is given to you on the DCAS, on the formula sheet. So you do not have to have that memorized right now, but you know, it's a good thing to memorize it, because in class, in Algebra 2, for example, you have to have it memorized, okay? Not for the DCAS, but you know, for your actual class itself. Okay, the A, B, and C that you see here in the quadratic formula are all this A, B, and C right here from standard form. So notice I first have to put it in standard form. Ax squared plus bx plus c equals 0. I said equal to 0. Then I have my A, B, and C. Now, being that you're beginners, I'm going to recommend that you write out what those A, B, and C are first before plugging it in, so you don't mess it up plugging it in. So all this is a form of plugging in numbers and then simplifying your radical, okay, and then possibly simplifying your fraction after that. But a lot of people mess up on plugging it in correctly. That's why I'm recommending you write out which letters are A, B, and C, what numbers are A, B, and C to begin with before plugging it into the formula. So I'm going to demonstrate that and do that. A is 1. I'm going to write A is 1. B is what? -6, not +6. You have to have the sign with it. C is what? -8, right there. This is what I want to see you do. Write it out. Now you go ahead and plug those numbers into the quadratic formula. Here's your plus or minus. Remember, we just got done with doing with that with completing the square, because that's going to be your two answers. This is another way, if you didn't complete the square, of coming up with those exact answers, irrational numbers. Remember, if it's underneath a radical, it's not a perfect square, it's an irrational number. That's how you're going to actually come up with the exact answers, or you could plug this in a calculator and get the decimal answer of where it really crossed the x-axis twice, that parabola. Okay, so say it's, there's one, say it's like this, and it might come down through here and come back up through here. Well, we don't know exactly where that is. Well, that's why we either complete the square or use quadratic formula to come up with those 2 points that are in between integers that don't factor. Okay, if it factored, I'd be able to just go ahead and factor it if you remember how to factor, but factoring only sometimes works. Quadratic formula here or completing the square that you just did always works. So that'll even give you the ones that come up at your integer points or fraction points as well that could factor. This always works, quadratic formula and completing the square. Factoring only sometimes works. Okay, that's why you really need to have this and get this memorized, because this will always work, and then be able to use it correctly. All right, so let's go ahead and do that. I'm not going to write out the formula because I have it right here on the page. I'm just going to start filling it in. It says negative b. Negative means opposite. So what is the opposite of b? B right now is -6, so the opposite is +6. I put plus or minus the square root. What is b squared? When I write substitute in, you must put parentheses. AJ is the one that would keep asking, well, you plugged it in, you came up with a negative. If you don't put parentheses around that, you're going to come up with a negative on your calculator. when you substitute something, you always put parentheses around it. We talked about that all year long. So there's my b squared minus 4 times a, parentheses I'm substituting in, times c, I'm substituting in. All over. You don't just say over, you say all over. 2 times a. 2 times a. So now I have 6 plus or minus 36. Because negative 6 squared is 36, not negative 36. If you forget your parentheses, you're going to come across with negative 36. Then your whole thing is wrong. 36. Next thing I want to do is I want to look at the signs and do my signs first before I multiply the numbers. You multiply all the signs together. So notice I have a negative here, a positive here, and a negative here. I can just ignore the positives and just multiply the negatives together. So negative times negative is a positive. Do the signs first. Even though I've just said that 2 or 3 times, there's going to be people in this class that don't follow my directions and aren't going to do the sign first, and they're going to try to do all the numbers together at one time, and they're going to end up with a negative there, and it blows their whole answer. Follow directions. 8 times 4 is 32. Now I do the numbers. All over 2. 2 times 1 is 2. So now I have 6 plus or minus the square root of 36 plus 32 is 68. All over 2. Now 68, 4 goes into 68. 4 is a perfect square. Remember, if you didn't know it, you start with half the number. 34. Go down to the next one, 25 doesn't go in it. Go to the next one, 16 doesn't go in it. Next one, 9 doesn't go into it. Go down to 4, 4 does go into it. So I have 6 plus or minus square root of 4 times the square root is 17. 4 times 17 is 68. All over 2. So now I have 6 plus or minus 2, square root of 4 is 2, root 17, all over 2. Okay. Now, even though that's correct so far, it is not simplified. So, along the way, the decafs might have any of these type of answers in here, and this would be one that says select all that apply. So they might have this answer as one of the answers. Then they might have this answer as another answer. It's not done yet. And then they finally have this simplified answer. And all of these are equal. They just, it's not simplified all the way. So if there's one that says select all that apply, if you show your work on your paper, that's why you don't try to do it in your head, you do it on your paper, and then you have each one of the steps written out, you might then see all of these written out on the decaf. It was under one of those select all that apply. So now, how do I deal with this? I can break this up into 2 fractions. Okay, 2 ways of doing it. I can factor out the GCF in the numerator, which is a 2. Then I'm left with 3 plus or minus root 17 all over 2, and then the 2's cancel. So the actual answer is 3 plus or minus root 17. That's your final exact answer. Okay. The other way of doing it is if I split this into 2 fractions, and I have 6 over 2 plus or minus 2 root 17 over 2. And that 6 divided by 2 is the 3 right there. And then those 2's cancel, and that's the plus or minus root 17 right there. Okay, your choice if you want to split into 2 fractions and then simplify, or factor out a GCF and then cancel your GCFs. Numerator and denominator there. You get the same answer. Okay, so this is the quadratic formula. So that means that parabola would have crossed the x-axis at 3 plus root 17 as one exact answer and 3 minus root 17 as the other exact answer. If they were talking about on the decaf, they might ask where it crossed the x-axis. They say find the answer to the nearest 100th or 10th. So now it's got to be a calculator problem. I'm going to type that in the calculator. 3 plus root 17, enter. Round that answer to the nearest 10th or 100th. 3 minus root 17, enter. Round that to the nearest 10th or 100th. Okay. But this is how you apply the quadratic formula. Again, if you need to pause that because you haven't written it all down, pause it, write it all down because I'm going to erase so I have room to do number 2 now. All right, number 2. Okay. Remember, I'm going to set it equal to 0. Right up here, remember this? I always set equal to 0 first in all quadratics, even if I'm factoring it. Okay, I'm going to set equal to 0 first, then factor out the GCF. Now, so I'm going to move this across. 2x squared minus 10x minus 2 equals 0. Okay, that's set equal to 0. Now, I could factor out the GCF, or I could divide by the GCF since I'm solving. If I'm solving, remember, if I'm solving, it's because I have an equal sign. If you're solving a quadratic, you can always, instead of factor out the GCF, you can divide each term by the GCF. Okay, remember there's 4 terms there, 3 on the left side, 1 on the right side. That's 4 terms total in the whole equation. And then that simplifies down to x squared minus 5x minus 1 equals 0. Now I just have smaller numbers to plug into that quadratic formula. I could have, so notice the directions were find the exact answer and to the nearest hundredth, because I told you the DCAS, well, you could ask for one or the other. So on yours, you type that in after you found that exact answer with the radical. You're going to then type that in a calculator and get your 2 answers rounded to the nearest hundredth right there. Now, I could have used the 2x squared minus 10x minus 2 equals 0 and plugged in the a, b, and c right there into it, and I'd still get the same answer as if I go ahead and plug in this a, b, and c. So remember, there's my a, there's my b, and there's my c. -1. So I'm going to write that out. Again, a equals 1, b equals -5, and c equals -1. Double check that all these with the correct signs are there. Because if you put one missing sign there, you said +1 at the end instead of -1, it blows your whole quadratic formula. So before you waste your time plugging it into quadratic formula, have it all wrong, and you end up with a negative underneath the radical. Remember, like I said, since we're in Algebra 1, you're going to always get a positive answer underneath the radical. Okay, if you can't with a negative underneath the radical, you probably did it wrong. I don't think they're going to put any imaginary numbers in Algebra 1. That occurs in Algebra 2. Okay, so that would have told me that you had a wrong A, B, or C, or you couldn't calculate B squared minus 4AC right. Okay, so now we're going to go ahead and plug that in. Remember, we're given the formula on the formula sheet. So -b. Remember, negative means opposite. So the opposite of -5 is +5, plus or minus square root of -5 squared in parentheses, AJ. So you get +25 minus 4a. Dang it. Come on. Let's see here. Let's just erase that. Minus 4, a is 1, c is -1. All over 2 times 1. Okay, so I have 5 plus or minus the square root of 25. You're going to always have a positive. When I square a number, so b squared is always going to be positive. Nobody better get a negative right there for b squared. Otherwise, you do not put parentheses around it if you put in a calculator. If you just use your brain and not use your calculator, you won't have to worry about that. Anytime you square a number is positive, you must have a positive answer right here. It must be positive. Right there, b squared minus, oh, it's not going to be minus, so we're going to do the signs. Minus 4 and a -1. We got 2 negatives, so change it to a positive. Now I do the numbers. 4 times 1 times 1 is 4. All over 2. 2 times 1 is 2. Okay, so, and this is x. This is the x-intercepts. Remember, in other words, you have x-intercepts. They're also called roots, and they're also called zeros or solutions. All those mean the same thing. You have to be familiar with all 4 words. Okay, so x equals 5 plus or minus the square root of 29 all over 2. Or all over. All over means long fraction bar. If I said 5 plus or minus square root of 29 over 2, that means only put the 2 underneath the square root of 29 only, not underneath the 5. So that's why I gotta say all over. That means a long fraction bar over everything you just said. Okay, so make sure you're pronouncing it correctly. All right, notice square root of 29 does not simplify, so these are my 2 exact answers. Then I'd plug the 5 plus square root of 29, hit enter, then divide by 2, and that's 1 decimal to the nearest hundredth. Then do 5 minus square root of 29, hit enter, then divide by 2, and that'll give you your other decimal, round each one to the nearest hundredth, and there's your answers. Okay. And that should be it. Yes. Okay, so that's all of chapter 11 right there in 50 minutes.